Let's talk about polar and rectangular coordinates. We're all very familiar with rectangular coordinates, and when we have a point that we define using rectangular coordinates, we give the x and y coordinate of that point. In polar coordinates, over here, when we describe that same point, we describe it in terms of r, which is the distance between the origin and the point, and theta, which is the angle that this ray makes with the positive x-axis. So it's easy to convert between rectangular coordinates and polar coordinates, and we can do that using trigonometry. So if we go back over here, we can draw a line, and we know that this is going to be the x-coordinate, this is going to be the y-coordinate, this is going to be theta, and x and y are the legs of a right triangle which has a hypotenuse equal to r. And if we apply the Pythagorean theorem, we know that r is going to be equal to the square root of x squared plus y squared. And we can see that theta is going to be equal to the inverse tangent of y over x. Now, if instead we are given the polar coordinates and we want to find the rectangular coordinates, we still have this as x and y as the legs of our right triangle. And now we can say that x is going to be equal to r cosine theta, and y is going to be equal to r sine theta. So let's look at just a brief example here. And the rectangular point that I want to look at is 0, 3. So if I plot that, that's going to be a point up here on the y-axis. And if I want to find the polar coordinates, r and theta, well, I can see from inspection that r is going to be equal to 3 because r is the distance from the origin to the point. And I can see that the angle that this ray makes, theta, is going to be equal to pi over 2. So I would write this as 3 comma pi over 2. But we need to remember that I don't just hit this ray once. I could go all the way around 2 pi and then come back. So really, theta could be equal to our original angle of pi over 2, or it could be 5 pi over 2 if I go all the way around once. It could also be 9 pi over 2. And of course, I could also measure clockwise, which would give me an angle of negative 3 pi over 2. So I have many options here. And there's actually one more option that I have, and I'm going to redraw my axes. And if this is the point up here that I wish to describe, which is still going to have r equal to 3, what I need to remember is that I could let r be equal to negative 3 and let my angle theta be equal to negative pi over 2 or 3 pi over 2. And what this negative sign tells me is that I go to the angle, which would bring me either over here using negative pi over 2 or this way using 3 pi over 2. But because I have this negative sign in front of the r, instead of drawing my ray down here, I'm going to draw it in the opposite direction. So that's an important additional thing to see that we'll learn about in exercises 1 and 3.